Hello everyone and welcome back to Nexus Olive Tech channel. In our last video, we officially started our robotics and drone journey. We talked about why Arduino is ultimate entry point for learning control system, and we took an overview of hardware, remembering that it is microcontroller packed with CPU, brain, memory and vital input-output ports. At the end of that video, I promised you that we would write our very first program. Well, today is the day. In this episode, we are going to learn what Arduino IDE is, how to install it and how it works, and we will build and code our very first project, the famous blink LED circuit, completely free inside the Tinkercad simulator. Let's dive in. Before we open our circuit simulator, let's talk about the main tools you will use to write your code. An Arduino IDE stands for Integrated Development Environment. Think of it exactly like Microsoft Word, but instead of writing essay or document, you are writing a line of code that tell your robot or drone how to move and think. In the Arduino world, the programs are called sketches. The program language we use is based on C and C++, but don't worry if you are completely beginner. It is heavily simplified so anyone can learn it step by step. Getting the software onto your computer is completely free and takes just a couple of minutes. First, open your web browser and head over the official website arduino.cc. Click on the software tab at the top of the page. Here you will see the latest version of Arduino IDE available for download. Select the installer that matches your operating system, whether you are using Windows, Mac OS or Linux. Once the installer downloads, simply open the file and follow standard on-screen setup prompts and click next to complete the installation. In just a few clicks, you will have professional development tool ready to go right on your desktop. When you open up the software for the first time, there are four key parts you need to know. First, the code editor, which is your blank canvas where you write your program. At the top left, you will see the check mark icon. This is the verify button. It compiles your code to check if you made any spelling or structural mistakes. Right next to it, it is the arrow icon or upload button, which takes your finished code or flashes it straight into Arduino board memory. Finally, there is a serial monitor in the top right window that lets you computer talks to Arduino board and see real-world sensor data scrolling by its real time. Now let's put our hands-on experience into practice. As we mentioned in the first video, if you don't have physical hardware yet, you can use the free online simulation tool called Tinkercad. Go ahead and open Tinkercad in your browser, head over the circuit section and click create new circuit. From the component panel on the right, we are going to drag three things into our workspace: an Arduino Uno board and standard LED and a resistor. This resistor is absolutely crucial because it protects our LED from receiving too much current and burnout. Wiring components is incredibly straightforward. First, look at your LED. It has long leg and short legs. The long leg is the positive terminal called the anode. Let's run the wire from digital pin 13 on our Arduino directly to that long leg. Next, take your 220 ohm resistor and connect it to the short leg, which is the negative terminal or cathode. Finally, run the wire from the other side of the resistor straight to GND or ground pin on your Arduino board. Just like that, our physical circuit loop is completely ready. Next, let's open up the code panel at the top right. Switch the drop-down setting to text and look at our sketch. Every single Arduino program is broken down into two essential blocks: setup and the loop. Inside the void setup, we write the code that runs only once when Arduino power up. We use the command pin mode 13 output. This tells the CPU that we want digital pin 13 to act as an output port, sending electrical power out to our circuit rather than listening for a sensor. Next comes the void loop. As the name suggests, this block runs repeatedly over and over again for as long as the board has power. To turn our LED on, we write digital write 13 high. This sends the full 5 volt out of pin 30. Then we use the command delay 1000 millisecond. This tells the CPU wait for 1000 milliseconds, which is exactly 1 second, while keeping the light on. To create the blink effect, we have to turn the voltage off. We do this by writing digital write 13 low, which drops the pin 13 down to 0 volt. We add one more delayed 1000 millisecond, so the light stays off for 1 second. Once the code hits the bottom of this loop, it jumps right back to the top and repeat the process forever. Now let's click the green start simulation button. Look at that, our LED is turning on for 1 second and off for 1 second, repeating perfectly. You have just successfully written your very first digital output and timing program. This simple project is a massive milestone. By understanding how to control a single pin using output signal and timing delays, you have unlocked the exact core concept used to pulse the motor on a drone or flash status indicators on moving robot. In our next episode, we are going to build on what we have learned and tackle a classic real-world application, traffic light controller. We will see how to coordinate multiple outputs using precise timing to simulate real intersection. If you found this beginner tutorial helpful, please hit the like button and drop the comment below if your simulation worked, and subscribe to the Nexus Olive Tech channel so you won't miss the next step of your journey. Thank you for watching, and I will see you in the next video.